So for this next video, we are learning how to drive the micro servo motor. This one is plastic gear micro servo motor. It's available in your module. So what is actually servo motor? Servo motors are controlled electromechanical devices which rotate precisely with a degree of rotation. Servo motors ideally consist of this one is a DC or AC motor, and it also consists in gear mechanism. In this motor, there is kind of gear mechanism and also feedback devices or feedback device, and also there is a electronic circuit to sense input or output from feedback. For example, pulse width modulation in this case. And the feedback mechanism in servo motor device usually they use potentiometer or rotary encoder. In this case, in micro servo motor, they usually use potentiometer as the feedback to detect the rotation of the shaft of the motor. The feedback is used to correct performance of the position. So basically, this one is type kind of servo motor, micro servo motor, and it has the orange and red and also brown cable. Three kind of cable. The first is orange. It is the input for pulse width modulation. It is the with frequency around 50 Hz with period 20 milliseconds. The variation of the duty cycle is usually range in 1 to 2 milliseconds. Okay, and this kind of a diagram of the standard for servo motor. Usually there is the input, which is the pulse width modulation or angle, and there is the controller inside of the motor. It is electronic circuit, and also there is the DC or AC motor, and there is the gear mechanism, and there is the output rotation, which is angle, and this angle as feedback measurement using potentiometer is measured using potentiometer or rotary encoder, which is a measure of shaft position, and this feedback to the controller and corrected the position of the motor. If you want to learn how to detail, you can see from the internet. This one is very good for you. How to mechatronics.com maybe is very useful for learning basics of servo motors. So basically, we drive the servo motor using pulse width modulation. In this case, I took this picture from your textbooks, and in the range of the duty cycle, it in 600 to 2400 microseconds, and with the period of 20 milliseconds, which is 50 Hertz. If you can see in here, this 3% duty cycle is maybe this one is 0 angle, 4%, 5%, 6% of 12%. Change the angle of the servo motor, and this kind of angle based on duty cycle input from pulse width modulation. For example, in here, if we put in the duty cycle with input 600 microsecond period, this angle is 0. And if we input the duty cycle to 2400 microsecond, we can drive the angle about 180 degree. I hope you understand this explanation, how to drive the servo motor using pulse width modulation. So next, this is a table from textbook. If you want to drive angle from 0 to 180, this one is fixed period of the pulse width modulation, which is 50 Hertz. 50 Hertz. This is full period, and duty cycle width on range in 0.6 to 2.4 millisecond. This one is frequency about 50 Hertz. Okay. This one servo motor, micro servo motor. In this case, we drive something like this. Okay, now we use the servo.h library to set the angle of servo motor. I took from your textbooks. I think it's too easy. In order to easy you understand, and here, of course, you first include servo.h from library, and this one servo, this one is object or servo catch, and in void setup you just go to attach object attach. It is the pin number, pin ponho, pin number, and in void loop you can write the angle either using dot write or write microseconds for duty cycle. In this range is 600 or 2400 microsecond. Wait a minute. This is microsecond. This one 600 or 2400 microsecond. Okay, this one object dot write angle or dot write microseconds. I just give the diagram from your textbooks. In here, this one is very easy to understand. I think for 0 angle, you put the value duty cycle. If you use write microsecond, you set the 600 microsecond. It means 0 angle, and 1500 for 90 degree, and this one 2400 for 180 degree. For example, you have object is my servo. This one is object my servo dot write. This one you just write the angle. Usually servo motor in general can rotate only 0 to 180 degree. And also there is a kind of the servo motor can run continuously 360 degree. It is depends on the mechanism. And this one is write microsecond. You write similarly. Just this one is 0. This one is 600. 1500 until 2400, 480 degree. I think this one is very easy to compare which microsecond you have to set for angle. Okay, I think this for attach pin. You can set in here, maybe if I'm not wrong, can set minimum and maximum for duty cycle. In this case, in example 0 degree, duty cycle is equal 600. Also you set, I think this one is 600, 180, 2400. I think this one for standard, I think no need for set this one. Can use timer 1, either pin 9 or pin 10. And this one using angle, you already know, right microsecond. Similar, right microsecond. Okay, I think it's very easy for you. Erase all ink. Okay, I go to next. So for first experiment, in this case, you just give the input. Our range is pin W, timer 1, I think timer 1, right? And red is middle, 5 volts, and ground. This one micro servo motor. You can place a shaft with the propeller of the micro servo motor. Okay, pin 9 for signal orange, red for 5 volts, and brown for ground. Okay, I took from textbook, I think. We use the servo.h. In this case, you use a pin 9. Okay, just define constant pin servo 9. And then create the object servo my servo. This one of object my servo. And invalid setup serial begin 9600 standard object dot attach pin number pin 9. In void loop, we just create angle. So we want to make and create the rotation between 0 to increment of 20 degree angle. 20, 40, 0, 20, 40, 60, 80, something like this. 100, 120, 140, 160, 180 last. Okay, and then object dot right angle. This one drive motor, that's on angle. Okay, and serial print angle degree. Serial print angle. Display angle on serial monitor. And delay. In a textbooks, maybe there is no serial monitor, so I include serial monitor in here in order to clearly see the angle in the program. And another program, you can use the delay microsecond similarly, but in this case using duty cycle, which is minimum duty cycle 600 microsecond for 0 degree. To 2400 for 180 degree. And this one is constant, pin 9. Create an object similarly. Main void setup, attach for serial monitor, pin attach is 9, and in void loop, I create the duty and duty on, and this one percentage, as you can know in previously there is some kind of percentage. This one 3, 4, 5, 6, 7, 8 until 12, right? Duty cycle percentage 3% until 12%, and this one convert to maximum and minimum duty. Okay, and this one just create a duty on for write microseconds. My servo dot write microseconds duty on. Okay, and this is just serial print duty percent and duty, and then delay for 1 second. Okay, I think no question for this. Is very simple and very easy, already in textbooks. And this one is using duty cycle, duty cycle, and this one using angle. This one is video from zero angle. This video is not run together. Should be run together. So this one using angle video. Okay. Okay, yeah, we just do now experiment 1. I already have in here servo motor, and here I just show you similar coding for servo motor. This one using angle. My servo dot write angle. Servo dot attach pin 9. Pin 9, okay, pin servo pin 9. Let's upload this one. Servo motor doesn't run, something very awkward. I don't know. It's late. Oh, something happened in here. Maybe there is not enough power. something wrong in his. Doesn't rotate back. Oh, looks like the power is very not enough, not enough power for this. Hmm. I think I should take off this all. Not necessary. Hmm. Forgive me. I don't know what is happened actually. This is a normal situation. Why it's gone for one? Is my code is something wrong? Is this again code? Really? Something read. Wait a minute. Oh, something weird. I don't know what is the reason, but it should be rotate like this, continuously rotate. Should be like this. Very interesting. Very interesting. Maybe I should take off this. This one is red positive. Should be put the power supply directly. I don't understand. Now it's function properly. Maybe voltage drop. Anyway, this one is should be rotate like this. Okay, I fix it. This one. That is using angle, and another is using the duty cycle. You can upload similarly the code. Oh, upload again. This one is percentage of duty cycle. Is represent the angle of the servo motor. 3% means 0 angle, and 12% means 180 degree. Okay, I wish you understand between the duty cycle and this angle is similar way. Similar. Okay, let's stop this servo rotation, and we can next for next experiment. Okay, for next experiment, this one is last experiment in our lecture. For second experiment, you can see in the page 260 in textbooks. Basically, we just control the rotation angle using potentiometer, which is in this case potentiometer go through input to analog 0, and this one is power source. This one micro servo power also put negative and positive in here. And this one is some kind of wiring diagram. I think you already understand this. Let's go to code. In code, is I think similar in textbooks. First, we define both in servo library and define minimum duty and maximum duty, and define the variable for servo pin, servo motor, and potentiometer pin, that is A0, and define servo as object for my servo, and go through void setup, and my servo dot attach pin 9 and serial begin 9600, and in void loop set the variable value or duty in here. The value is from potentiometer. This is analog read, which is range from 0 to 1023. And using map function, you mapping the value from 0, which is minimum 600 in here, and maximum 1023. This is maximum in here for duty cycle 2400. And using microsecond, right? Microsecond. Typing duty in here, how much value for microsecond duty, and then go to serial print. This is just a print of duty cycle between analog and duty and delay. And this one is when you rotate tensiometer, the servo motor will follow the this one is when you rotate the potentiometer, the value is follow the decimal, and this one is duty number. Okay, and then homework. Wait a minute. And this one sketch using potentiometer. Oh, this one using angle. Yeah, this one angle and duty. I put two kind of code, I think same in textbooks. First is angle, first is duty. Okay, just go to duty. Just upload this code, and I have to attach this again. We already upload, and you can rotate of your potentiometer based on where is the serial monitor. So this one is value between potentiometer and duty cycle. This duty cycle is about almost 2600. 2596 is about. This depends of the value of potentiometer. I think the video is hanging. Something problem. Anyway, you understand how to the code. Actually, basically, it's very easy. Okay, now the homework. In homework is a combination. Your homework is actually very easy. Very easy. This homework is combination of experiment 3 DC motor and experiment 2 servo motor. So you drive together the DC motor and servo motor together. The text is drive together DC motor and servo motor according to potentiometer value. Okay, and there is also switch button to change rotational direction of DC motor. Only DC motor. Okay, we already learned how to do this, and also this display angle and PWM value on serial monitor. Angle of servo motor. This one. Display angle of servo motor. And the tips is this one. For speed changing like this, and for angle using map something like this. I think it's very easy. And this one is just for button. If digital read equal low, we change this directional of DC motor. And you have to use the driver motor. This one is pin attachment for driver and servo motor, and also potentiometer using A0. I think it's very easy for you. Okay. I hope you understand this schematic diagram. We already learned in this lecture. This kind of a video, maybe something you this vibrate because the not stable of the value of potentiometer. is fine. We just rotate potentiometer and drive this DC motor together. This one rotates maximum. And this is switch button, just change direction of DC motor. Something like that. Very easy, right? And also display the angle of servo motor and also motor speed on PWM. Okay, I wish you understand this homework. I think it's very easy. It's combination in our lecture. If you study in our lecture and understand, I hope you understand my language. Okay. So thank you for your attention and have a good day. And I wish you have a good, healthy, and safe at home. Stay safe. Have a good day. Thank you very much.